this video, we're going to talk about the reciprocal trig functions. Now, more often than not, we have all been exposed to sine theta, cosine theta, and tangent theta. However, we do have what's called the reciprocal functions. And the reciprocal functions come from when we are looking at any right triangle and we have theta. We know that the side across from theta is our opposite side. The side that touches theta is our adjacent side, and the longest side, always across from our hypotenuse, always across from our right angle, is the hypotenuse. So the trig functions come from when we take sine, cosine, and tangent, and we take the reciprocal of their ratio. So we know that sine, the ratio, is opposite over hypotenuse. We know that cosine is the adjacent over hypotenuse. And then tangent is always opposite over adjacent. Well, if we take the reciprocals of that, the reciprocal of sine of theta gives us hypotenuse over opposite, which gives us a new function. And that function is called cosecant of theta. Now, cosecant of theta represents the hypotenuse over the opposite side. So if you take the reciprocal of cosecant theta, you wind up with sine of theta. They do go back and forth, so keep that in mind because that'll be very helpful for us later. However, once I take the reciprocal of cosine of theta, I wind up with the hypotenuse over the adjacent side, and that gives me secant of theta. And the same thing for tangent. We have the reciprocal, and we get the adjacent side over the opposite side, and that gives us cotangent theta. So using these new trig functions, we can use them to solve more problems throughout our right triangles. So let's look at an example. This first problem says that secant theta equals 5 over 4. They want us to find tangent of theta. So what I'm going to do is I'm going to draw any given triangle. Doesn't matter what it looks like as long as it's a right triangle. And I can place theta anywhere that I want. I can do this because, again, it's just a representative of any unknown angle. So when I start looking at these types of problems, I want to be able to fill in my triangle. However, I need to know where to put my sides, right? So I know that secant is the reciprocal of cosine of theta. So if I take the fraction and I flip it for secant of theta, I will wind up with cosine of theta. And that helps me because now the adjacent side is 4, the hypotenuse is 5, and that'll allow me to find my missing side. So using the Pythagorean theorem, I can take 4 squared plus x squared equals 5 squared. That gives me 16 plus x squared equals 25. Subtract 16 from both sides. That gives me x squared equals 9. Take the square root of both sides and we get x equals 3. This is a special kind of triangle. It's actually a Pythagorean triple. That any right triangle where the legs are 3 or a leg is 4 with the hypotenuse being 5, we can assume that the missing leg is either going to be 3 or 4. And if they're given both legs of being 3 and 4 and they're like, what's the hypotenuse? We know it's going to be 5. There's many different Pythagorean triples out there. Any multiple of 3, 4, and 5, such as 6, 8, 10, and so forth, all of those are going to be Pythagorean triples as well. So now that we have found our 3 sides, we can finish our answer by finding tangent of theta. So tangent of theta, we know, is the adjacent side over the opposite side over the adjacent side. And that's it. So tangent, opposite over adjacent, that gives us our problem. So easy. Let's look at one more. So on this one, they want us to find secant of theta. So for secant of theta, I know that it's the reciprocal of cosine, which cosine of theta is the adjacent side over hypotenuse. So we know that secant of theta is going to be the hypotenuse over adjacent. Well, we have the adjacent side down here as 10, but we don't have the hypotenuse. So I need to find the hypotenuse. So using the Pythagorean theorem, and I like this example because a lot of times these types of terms here really confuse us when we're squaring them out. So we have 4 times root 6 squared plus 10 squared equals x squared. So whenever we have a problem like this, this squared is going to square every piece of our term. It's going to square the 4 and it's going to square the 6. So what that's going to look like is I'm technically going to have 4 squared times, well, root 6 squared plus 100 equals x squared. Now, simplifying this, we know that 4 squared is 16. Anytime that we square a radical, the radical and the squared term, they cancel each other out, and I'm left with whatever is just under the radical, okay? So we have 16 times 6 plus 100 equals x squared. Keep simplifying, and that's going to give me 96 plus 100 equals x squared. Again, 196 equals x squared. Take the square root of both sides, and we get x equals 14. Here we can set our hypotenuse equal to 14, x equals 14, and we can finally find our secant of theta. Secant of theta is the hypotenuse over the adjacent side. So secant theta equals 14 over 4 root 6. Now, we don't necessarily want to leave our answer like this. I want to simplify. I don't like leaving radicals in the denominator. So we rationalize, saying 14 over 4 root 6, and we're going to multiply top and bottom by root 6. And what happens here is that gives me 14 root 6 over, when I multiply these, the radicals are going to cancel, giving me 4 times 6 equals 24. That will simplify, giving me, we can factor out a 2 out of them, giving me 7 root 6 over 12 to give us secant of theta. That's a good simplification problem right there. So depending on, how much simplifying you need to do, that's it. Either answer will suffice.